Assalamu alaikum, and this is the screencasting for lab 7. In the previous lab, we have talked about how to get the single mode and the frequency table. So in this lab, I'm not going to go through this again. So please, if you haven't watched the previous video, just watch the last, I guess the last hour. The last hour contains calculating a single mode and how to write a frequency table. In this lab, we're going to talk about how to get multiple modes, how to write an algorithm or a program that gets you multiple modes from a list. And then we're going to talk about file processing, which is going to be really essential for you in your assignment regarding reading from files and writing into files. And by files formats, we mean that we're going to talk about text formats. And it's the easiest format that we have, and this is the one I've discussed inside the lab. Maybe if there's time by the end of the video, I will make an optional segment where I'm going to talk about CSV. I'm really sorry. We're going to talk about CSV or Excel sheets. So you would have like a wide variety of files that you can interact with, but our main focus is basically text files. All right. So without further ado, let's just first recap what we have done in the previous lab. I told you in order to get the mode or the frequency table, let's talk about the mode itself. If you want to get the mode of any list, you need to count all the elements of the list to know which one of these elements has the highest frequency, right? So what is the function that you use to count that counts the elements for you? The function is called counter, but the counter function isn't really a core function. You don't find this by default like the print or the input or the casting functions. You will find only this function in a module called collections. And just to reiterate, a module or a library is basically a script that contains multiple functions. And from that script, you take whatever function that you need. You can import the whole library, and as well you can import only one or two functions from that library. And this is what we're doing here. We're saying, and this is the first line that you should do in your script if you are calculating modes or writing a frequency table. You should first say from the collections module, import the counter function. All right, now prepare some list in order to count the elements of that list and get the mode of that list. By looking at this list, you can tell that you have multiple modes here. The first mode that appears in the list is 10 because its count is 2. The next highest frequent element or most frequent element is 2. It appeared twice. And the third is 8. That appeared also twice. And 20 appeared only one time, and 5 appeared only one time. Alright, so now we use the counter function and we pass this list or any list that you have to the counter function in its parentheses. What does the counter function return is something like this. It returns each element with its count. It returns each element with its frequency, but without any order regarding the frequency. Alright, it just returns them by the order of their appearance. Like whatever element that appear first gets counted. So here the 10 has appeared first in the list, so 10 has been counted and it has a frequency or a count or number of appearances of 2. Then the next element that appears in the list is 20, and 20 has appeared only one time. Then the next element that appears in the list is 2, which appeared only 2 times, and the next element that appears in the list is 5, and it has appeared only 1 time. And finally we have 8 that has appeared only 2 times. This is a mistake, guys. This is a mistake. It should be 8,2, not 8,8. I'm really sorry about this. Okay, so this is the kind of list or object that the counter function returns. Once you have this, you should actually store this in somewhere, in some variable. This is why I'm doing something like a variable equal on the right hand side of the counter function, telling Python that whatever this counter function will return, which is in this case this object, please just save it in a variable because I'm going to use it afterwards. Now the thing that we have saved here, this object that we have saved here in C, what we are doing on it right now is basically we're saying, please, whatever has been saved into C, which was the return of the counter function, just take it and apply a method on it that is called most common. So what does most common do? Most common basically sorts the object that has been returned from the counter function that we have saved in C. It sorts it from the highest frequency to the lowest frequency. So basically it creates, and the most importantly, it creates a list. Notice that whatever the counter function will return isn't a list. It returns some kind of pairing like this. It returns pairs of the element and its count, but it is not a list. something called a dictionary. That's why I don't want to get into full details about this, but just know something that most common do two important things. It creates a list of the returned object of the counter function that we have stored and saved in C. That's one. And the list that will be created by most common will be sorted from the highest frequency tuple to the lowest frequency tuple. Meaning that now we will have 10, all right, with which basically the highest frequent or the most frequent element. You might ask, why isn't 2 is the first tuple, or why isn't 8 is the first tuple? Because like 10 has frequency of 2, and also 2 has frequency of 2, and also 8 has frequency of 2. So why does 10 appear in the beginning? Well, basically, if you have multiple modes, meaning that each mode of these three elements, which are 10 to 8, if they have the same highest frequency, which is 2 in this case, the one that appears in the beginning is basically dependent on the appearance of the element. Like the element that appears first is basically the one that gets in the first tuple. So basically here, the first mode that we meet in this list is basically 10. So this is your highest frequency element, or your most frequent element with its count, 10, 2. This is the first tuple. Okay, the next tuple is the next highest frequency, or the next most frequent element, which is 2, 2. Then the next tuple is basically the next most frequent element, which is 8, 2. And the next will be the next most frequent element, which is in this case 20, 1. And lastly will be the least frequent element, which is basically 5, 1. Okay, now this tuple here is at index of 0, and this tuple here is at index of 1, and this tuple is at index of 2. So basically, if you stored what does most common return is basically something like this list of tuples that we have discussed in the previous lab 6. So this list of tuple, I need to work on it. I need to know, I need to store it, I need to access maybe the first tuple, maybe the mode itself, maybe the count of that mode, right? So I need to store this list of tuple, and this is why I'm having a variable on the left hand side of the most common method, saying that whatever the most common method will return, please just store it in a variable. And I call this variable all frequencies for a reason, because it's more meaningful. You don't have to name it X or Y. Just name it something meaningful to you, knowing that this list of tuple contain each element with its frequency. Each element with its frequency. So you have all elements with all frequencies. This is the reason of the naming of the variable. Alright, so now if you have this variable, which is basically the return of the most common method, which is basically this list of tuple, and you want to access the first tuple, and the first tuple by default is basically the highest frequency tuple, or the tuple that contains the element, which is it's going to be by default the mode and its highest frequency, which is going to be the count of that mode. So if you want to get the first tuple, you're just going to access this list and use the first index, which is index of 0. This is going to get you the first tuple. And if you want to get the mode itself, and speaking in this case, we're just talking about the easiest way of getting the mode, which is the single mode. If you want to get a single mode, this is your way to do. And this is what we have done in the previous lab when we were calculating the single mode. Things are going to be a bit different when we are talking about the multiple modes. Okay, so if you want to get the single first most common mode, so you're gonna say this tuple that is located at index of 0 of this whole main list. Okay, from this tuple, get me the first element, which is at index of 0. You see, a tuple is just as ordered as the list is. So you have the index of 0, this is a start, and an index of 1. So from this tuple, which is basically corresponds to this part, get me the first element, which is at index of 0. So the next access brackets get you the index of 0 of that tuple. So you get 10, which is basically the mode. All right. And if you want to get the count of that mode from the same tuple, this what gets you the same tuple, yeah? So from that tuple, get the next element, which is basically the frequency of the element on the left, right? It's the frequency of the 10, right? So if you want to get this 2 is located at 0, 1. So this is the position of 2, which is 1. So the next accessing layer is going to be to access the element at index of 1, which is 2 in this case. So you're going to get the mode count, all right? Now, the list of methods that we have taken before is basically append, sort, count, reverse. We have taken multiple ones. If you want to know exactly what list methods we have taken, you can find this in your fourth lab, I believe. In your fourth lab, yeah. But the one that we want to focus on today is basically the append, and this is just a reminder for you that the append works like this. You have an empty list, right? And you can append to that empty list saying that whatever is going to be written, whatever values that's going to be written in the parentheses of this append method will be inserted into that list on the left, right? So now we are inserting Ahmed to this names list, which is an empty list, and we are inserting or appending Ziad to this empty list, and we are appending Barry to this empty list. Okay. In the previous lab, we have talked about how to make a frequency table, and I have done the frequency table in the previous video. I think it was the last program with functions and without functions, and we have done the enhancement of the program where we started sorting this frequency table by the numbers from ascendingly from the lowest to the greatest. Yeah. So now we're gonna talk, yeah, we have made also the calculate mode function, how to calculate a single mode, and this is really easy, and it's the same concept as this here. This gets you the mode, then this gets you the count of that mode, but this is a single mode calculation, right? Which is really what is required in this program. Now, what we are talking about right now is finding multiple modes in a list. And this was essentially an in-lab challenge where I gave students like 10 to 15 minutes to try on their own. And surprisingly, most of them have done it correctly, especially, I believe, especially what it was group. Yeah, again, it was group 4, Yusuf, Tamer, and Rana. This group, they have done this on their own. It was a great challenge. So this is with the same concept that we have done the in-lab challenge where we were finding the median. We are now finding the mode, the multiple mode. So take a break and give yourself, pause the video or look at the slides, give yourself 10 minutes and see this walkthrough, this algorithm walkthrough, and just try to understand what is the steps is telling you. What are the steps are telling you? This is basically the algorithm or the pseudocode for this multiple mode calculation. Try to understand this, and eventually you're gonna get it correctly. So let's see how can we approach this. Now, you see here that you have a list. This is the list that we are working on. If you look at this list, you'll see that you have multiple modes. The modes that we have in this list is basically 66, 88, and 9. Right? These are the modes that we have. But how can we create a program that gets me every mode out of those? Now we know that these are the couple of lines that we know so far, like importing the counter function from the collections, having the list there at somewhere in my script, using the counter function on that list to count each element but not sort them from the highest frequency to the lowest. Save this in a variable, call it C for example. On this saved object that is returned from the counter that we have saved inside C, we will apply on C, or the returned object, the unordered object, we will apply the most common method, which will basically return a list like this, a list of tuple that is ordered from the highest frequency to the lowest frequency. And you can see that is ordered from the highest frequency, which is 66, then followed by 88, which is the next most frequent element that has appeared, followed by 9, which is the next most frequent element that has appeared. Then you start seeing that the frequency drops by 1, then drops by another 1. So you understand that the modes here is 66, 88, and 9. Notice that the common thing between these modes is that they have the same highest frequency. Okay, these 66, 88, and 9, all of them has the same exact matching frequency, which is 3, right? So if the first step was doing the previous 3 lines or 4 lines and storing this list of tuples in all frequencies, what we can do is basically if every mode in each tuple, right, if every mode, which is 66, 88, 9 of each tuple has the same frequency, which is index of 1, which is the next element or the second element of each tuple, yeah, if each tuple has the same frequency, which is index of 1, then I can tell that the element on the left, which is index of 0, is basically a mode. Until we find something that does not match, until I iterate over the next tuple, which is this tuple, and I see that now the frequency, which is 3, is not equal to. So basically, once we have an unmatched frequency, we know for sure that this element on the left of this tuple that we are standing on or reviewing is not a mode anymore. So our modes have stopped in the previous iteration. Okay, so the first thing that we need to do is basically saving the highest frequency. You know that the highest frequency, as I told you earlier, the highest frequent element or the most frequent element and its count, you can find this always in the first tuple. So using the knowledge that the first tuple always includes the highest frequency, we are going to say that from the first tuple, I'm going to save the second element of this tuple, which is basically at index of 1. I'm going to save this in a variable and I'm going to call it maximum, which stands for maximum frequency, or for short, just max. Okay. The next step, which is the most important one, once you have the highest frequency, which is 3, what you can do now is use a for loop to iterate over each element, and by each element I mean each tuple. Okay, if you iterated over each tuple, what you can do once you iterate over a tuple, or once you are currently standing on this tuple, is to get from this tuple the second element. All right, get the second element from each tuple and compare it with maximum. If maximum was equal to the second element of each tuple, then we know for sure that the element on the left, which is index of 0 of the same tuple, is basically a mode. If it is a mode, if there is a matching between the maximum frequency that we got in step 2, if there's a matching between maximum and the second element of the same tuple, then we will append this element on the left of the same tuple, which is basically index of 0, into an empty list. Let's call this empty list something like modes. All right, so we're gonna append 66 in this case. The next iteration, we are going to hop on to the next tuple, and from the next tuple we are going to use the next element or the second element of this tuple, which is at index of 1, to compare it with the maximum. If there is a matching, like double equal signs right here, then we know for sure that the element on the left of the same tuple, which is basically at index of 0, is another mode that I can append. Then I'm going to take this element, which is 88, append it to modes as well. In the next iteration, in the next hop, I'm going to be on the third tuple. So when I have the third tuple, or this tuple for example, I'm going to do the same thing. I'm going to say if maximum equals the second element of this tuple, which is an index of 1. If there is a match, if this if statement or condition yielded to true, I'm going to append the first element of this tuple, which is 9 in this case, at index of 0. I'm going to append it into modes, because this, if there's a matching, then this means that X is going to be another mode that I have. Okay, I will hop to the next iteration, I will hop to the next tuple. Now I'm going to compare with the same exact fashion. I'm going to compare the maximum frequency that I have stored, which is 3, with the next element or the second element of this tuple, which is 2. There is no matching here. 3 does not equal 2, right? So there is no appending will happen to the element on its left. There is no appending that will happen to the index of 0 of this tuple, because there is no matching anymore. And once we have an element that does not match, we will never have a matching anymore, because what does most common do is that it sorts them from the highest frequency to the lowest frequency. So if we are seeing at the first 3 or 4 tuples, for example here, at the first 3 tuples we are seeing 3, 3, 3. Once the 3 drops, it will never go back to 3. You will keep seeing this frequency dropping like this, because it's ordered from the highest frequency to the lowest frequency. Now by the end of the program, I want you to do something like this. I want to have the output displayed like this. Like we have the first mode, for example, is 66, the next mode is 88, and the third mode is basically 9. Okay, so how can we do this? Well, basically, if you have understood the algorithm, then writing the code is going to be really easy. All right, so notice that we are saving the highest frequency and we are iterating. There are 2 essential steps, that's it. Okay, so I'm going to take this part because we are going to need it. and I'm going to paste it here. Okay, I'm going to do this at the beginning without a function, and I'm going to tell you how can we modify our code in order to write this inside a function. Okay, so let's just print all frequencies and see what does it include. So all frequencies has this tuple. It's the same list of tuple that we have seen here in this screenshot. Now, I told you that for sure you can get from the first tuple the highest frequency and the mode of the elements. All right, the first tuple always includes a mode, whether it's a single or multiple. It always, bottom line, it always includes a mode, and it always includes this count of that mode. All right, so what we can do, which is basically step 2, is save the highest, highest frequency in a variable that we will use for comparison later. All right, so let's say that this variable is called maximum. Let's call it maximum frequency. All right, so maximum frequency is going to have 3. This 3 is found in the first tuple, and the first tuple you can get it from all frequencies of 0. This gets you the first tuple, which is basically, in this case, 60,3. Yeah, so now you want to get 3, which is the highest frequency. So you access one more time this tuple, and you say that now you want to get 3, which is at index of 1. So this is going to get you 3. Okay, so this is step 2. Now step 3 is basically comparing the maximum frequency with every other frequency in every tuple. And notice that every other frequency is located at index of 1, which is essentially the second element of each tuple. Okay, so comparing every frequency in every tuple. And when you say in every tuple, you mean that you need to iterate over the list of tuples using a loop. Okay, so let's say that this is my for loop for xn, for example, for x in the name in the list name, which is named all frequencies, and let's print what? Let's print, come on, let's print x, and just let's see what's going to be printed. Notice that x that is printed right now is basically x resembles or represents each tuple or each element from that list. This list is what we have here. Okay, so x is basically each element from that list. Okay, so x at the first iteration is this element, x at the second iteration this element, and so on. Okay, what we need to compare is basically our maximum frequency that we had in step 2, which is 3, which with each second element of each tuple. Remember that each tuple is x, and from that x, from each tuple, we want to get the second element. So the second element of x is basically x of 1. The first element of x is basically x of 0, and x of 0 represents the number themselves, right? The elements themselves. What we want to compare is x of 1 from each tuple, which is basically the frequency of each element, right? Not the elements themselves. So I'm going to say if maximum frequency equal, if it was matching one of those elements on the right, one of those second elements of each tuple, which is x of 1, which is basically the second element of the tuple, which is x in this case. If there is a matching, then this means that 3 matches. For example, if we have x as the first tuple, then 3 equals x of 1 of the first tuple, which is 3. Then this means that the element on the left of the same tuple, which is x of 0, is basically a mode. So I'll need to append it in some empty list. So let's create an empty list and call it modes. All right, so if there is a matching between x of 1 with maximum frequency, which is 3, the one that we have stored at the beginning, then this means that x of 0 is a mode that I need to append inside the empty list modes. So I'm going to say modes.append and then I'm going to append the element on the left of the same tuple. Remember, the same tuple that I'm talking about right now is x. What we have used from x is two things. I have used from this x or this tuple the element on the right, which is x of 1, to compare. Okay, if the comparison yielded true, then from the same tuple, which is x, I'm going to take x of 0 to append whatever mode or whatever element on the left. Okay, because if there's a matching, if there's a true return from this condition, then this means that the element on the left is basically a mode, so I need to append it, right? So I'm going to append the element on the left, which is basically x of 0. Now this loop, now that's basically the code here. Okay, this loop will go over in the to the next tuple. For example, x is going to be the next tuple, and remember our maximum frequency was basically 3. Okay, so if my maximum frequency is equal to the x of 1 of this is x and this is x of 1. If maximum was equal to x of 1, then append x of 0. Okay, because if there's a matching, this means that this is a mode. Next iteration, x is going to be the third tuple in the third iteration. So basically maximum, if you compare it to the x of 1, which is 3, if there is a matching, and in this case there is a matching, so append the element on the left of the same tuple, which is x of 0, the first element, because that's a mode as well. Once you get to the fourth tuple, you're gonna see that when you compare maximum with x of 1 of this tuple, which is x, there is no matching here. So basically this f will never execute. So 11 will not be appended. The same goes for the next couple of tuples. Okay, now if this is done, you can actually print the modes. Now run this, and you're going to see these are the modes that we have. Let's say that we increase the number of modes here. Let's say that we have another mode. Let's call it like 7. When you run, you're gonna find that 7 is basically another mode that you have. Right? Now, what is left here is to get the output in this format. If you see this, you can actually tell when you see that multiple lines and this mode word is repeating. Basically, if you have 1,000 modes, you cannot actually think that you're gonna write a thousand print statements and write in it mode, then whatever, mode of 0, then mode of 1, then mode of 2. When you see something like this, immediately think of a loop. This loop will generate this kind of shape of multiple sequential lines, right? So let's make a loop to print the modes that we have gotten so far. So let's say for example x and whatever. The thing is here, the modes, we have like 4 elements in the modes list, right? So basically this loop needs to continue for 4 times, right? So for x in modes, let's say that we are going to print the mode, yeah, we are going to get the mode like this. Let's use an f string. I think this is going to be better. Yeah. Okay, so the mode is going to be x, and the mode count, remember the mode count is basically 3, right? And this is what we have stored in maximum frequency, or let's say frequency like this will be maximum frequency. All right, so let's run this, and we're gonna see that these are the modes that we have: 66, 88, 9, 7, etc. And at each frequency of that, and the frequency of each mode is basically 3. We can actually make some spaces because this doesn't really look so good. All right, now run this. I think this is, it still doesn't look so good, but whatever. This is the required thing in this program. Now let's see how can we do this inside a function. I'm going to copy everything, and I'm going to make a new trial. Let's call it trial2.py, and let's copy this, take it to the right hand side. And I don't want to see any comments because this is unnecessary and it's just distracting. Okay, so remember that this list is our test subject, so we need a function. So let's call it, for example, mul modes, which stands for multiple modes. And this list basically gets you the mode of a given list. So it takes a list, right? So let's say that I'm going to indent everything inside this function. All right. And there's only a slight change that I will make here, is that this counter counts actually the elements of any list, like this, and this is it. If you want the function to return multiple modes, and we can do this actually outside of the function, I will tell you what I mean by this, but let's say that this is my function definition, and this is the list that I will test my function on. So this is the list that I'm testing my function with, right? So let's call the function multiple modes and pass list 1. Now run this. You should get the same exact results, right? If you don't want to see this printed list of tuples, and you don't want to see this printed multiple modes, you can actually remove this print function from there, and from there. Okay, run this, and you're going to see this table, sort of tabled thing for multiple modes. Now, if you want to make this function return multiple modes, then what you should do is actually, you can actually take this for loop out of the way and say that whenever the modes are calculated, now just return the modes like this. Let this function return the modes. Now notice, if there's a return now, we should actually store this in a variable. Let's call it something like return modes. Okay. What is wrong here? Expected this block. Oh, I removed this by mistake. There's an appending here. Okay. Now let's just remove the indentation from this part because we are out of the function. And now we're saying that for xn, remember that this modes thing was inside the function. So basically, when you get out of the function, this modes is no longer available to you. It's out of your scope. It's out of the domain of the function. But this modes is actually returned from this function call, right? And it is saved inside returned modes. So basically, we are iterating over returned modes right now, not modes, because modes is no longer reachable for me. Right now, remember something, that we are here, we need the frequency, which is the maximum frequency. And if you remember, the maximum frequency has been calculated locally inside the function. So it's the same problem that we had with modes earlier here, right? So maximum frequency is out of my reach because it is inside the function, and we cannot get it outside of the function unless we return it. Yeah, so let's return maximum frequency as well. Now, notice something, that what will be returned right now is a tuple. Before doing this for loop, I just want to show you what this returned object will be looking like. So let's print the returned, let's call it returned tuple. So this is my returned tuple. The returned tuple will contain, first element is going to be the list of modes, the list of multiple modes, and the second element of this tuple is going to be the maximum frequency, right? So we can say that this loop will iterate over the returned modes. There is nothing called return modes right now, it's called the returned tuple. So what do we need from the return tuple? We want the loop to iterate over the list, which is the first element of the return tuple, which is basically the modes. So the first element of this return tuple is basically at index of 0, right? But the problem with this one's gonna throw you an error telling you that there is nothing defined as maximum frequency in this scope. It is inside the function, yeah, but there's nothing here outside of the function called maximum frequency. But we have returned it from the function, and we have stored it in the return tuple, which actually it's the second element of this return tuple. So we can say from the return tuple, get me the second element, which is index of 1. Yeah, so if you run this, you are going to get the same exact result. Okay, if you don't want to see this print of return tuple, then this is what you have. I hope this is clear to you. the problem didn't actually state anything about the frequency, so you could actually stick to the returning only modes or like this, and you know just make the loop iterate over the return modes like this, and just remove this part. You could have actually stopped at this point, but I just wanted to like extend on what you can do. And as well, since there is no specification on what you should do, there's no telling if you should do this inside the function or outside the function. So you can do this without a function, right? And you can do this inside the function. And since there is no specification on the function on the function details, whether you should return inside the function or you should only print inside the function, then you could have done only the same thing that I've done at the beginning, like including the print inside the function, like this. Remember when I included the print inside the function? This was the first version of the function that I ran, like this. If you have the print inside the function with no return, this is fine, since the program didn't tell you what you should do. But if the program is telling you that you should make a function that returns, then this is your solution. All right? Now, remember that inside the assignment, it is really important to make functions. You will be graded on functions, so do not forget this. Okay? Now, okay. So let's take the final part of this lab, which is file processing, reading and writing into files. Let's take the first one, which is basically writing, or when you see writing, it's basically like printing. It's the same concept of printing to the terminal, but instead we are printing or writing into files. See, what we have been doing so far from the last semester and up until now is basically writing everything, or let's say printing everything inside my terminal. See, this print function and this print function, this print function, everything was addressing this terminal right here, our you can call it console, terminal, cmd, whatever. Okay, so everything that was printed in my terminal, right? This will be a little bit changed. Now we are no longer printing inside the terminal. What we want to do is that, let's say that this is the folder that we are working on. I'm working on a folder that's called lab 7 script screencast. Okay, you can find this folder in my desktop right there. Okay, this is the one. So let's say that this is the folder, this is the same folder that I am accessing from VS Code, that I'm viewing in my workspace area here, okay, that has trial 1 and trial 2, and both of them are Py scripts, they are Python scripts, okay. But instead of printing the result or the output in the terminal, now I want to create something like this. I want to go to my folder and create something like a text document, for example. I don't know, and name it, for example, output. All right, now what I want to do is create a folder or a file like this, a text file like this, and instead of printing to the terminal, I want to write this output. I want to write this, for example, this table, mini table that I have in my terminal, I want to write it in this text file. Okay, so whenever I open this text file, I should see the same result that I'm seeing in my terminal right here. Okay, so how can we do this? Well, why is this important? I'm going to discuss this with you by the end of the lab. I know that you might ask yourself, like, why is this important? Like, we are printing already in the terminal, so why would we need something like this? Basically, in a field called data analysis, this is really important. You need to have something like a log or a history of your data, right? You need to know, you have simulated a system, for example, a bank or a supermarket or something. And this is really an important topic in a course called modeling and simulation. You can find a book for it. I can recommend you a book for it. I think I have it right here. Modeling and simulation. Modeling and simulation. Where is it? Okay. I will just pause the video by the end of this segment, after the read and write segment, and I will tell you the reference or the book that it talks about modeling and simulation. And this field is a very important field in computer engineering that actually includes everything that you are taking in this semester regarding mathematics, starting from statistics and probability, and there are so many other stuff that is not included in your course, but you will find it in something called modeling and simulation course when you get to the next year or the year after, I believe. And it addresses this field, like using mathematics and statistics and probability. We want to study, is it important for us to like simulate using code a system before we actually embark to build it? Like, is it efficient for me to build, for example, a model that will cost me like $1 million, just without any planning, without any study? I know that it is not. Yeah, there's nothing like this. You need to study. You need to study stuff first. You need to make a case study or a study table. I don't know what they call it in business. You need to make a business model and stuff like this. But the most important thing from our technical aspect, from our point of view as data visualizers or data scientists, is to basically to be able to simulate the whole system with the staff inside of it, with the cashiers, the counters, the servers, yeah, with everything inside the system. We need to be able to simulate it for example, a couple of time, for maybe a minute, 2 minutes, 3 minutes, a month, a year, 1,000 years. We can do this kind of simulation, and we can do the statistics in this simulation, right? We can calculate the statistics, like having the average arrival time, like how many customers do arrive in every, for example, in every 5 minutes. What is the service time that we have, that we are providing at each counter, at each cashier? Does each cashier actually take so much time in order to service some customer, or is the service time is like is as least as it could be? And this is a good thing when your service time is lower than like an average service time or something. So you're gonna have some statistics, mean, average, and maybe you're gonna have variance and standard deviation if you want to plot some things and look at your final model, right? This is the start of machine learning and data analysis or data science. So basically, having the ability to save your data that you have actually acquired from this code in a log that you can open afterwards and look at some point of time to review if this system is doing well or not. This is really essential in the field of data science and data analysis. And this is what data analysts do in companies, big like companies like Google and Facebook. All right. Say that, for example, you are working on an application like Twitter or something, a social network application, and you want to see what was the most clicked link, or the most clicked tweet, or the most clicked trend in the previous, for example, 24 hours. So what you will do is not going to the application website itself and search for it on the browser. No, you would have like a testing server for this application, and this testing server that you have deployed, like every now and then it generates something. It generates a log that you can look at, right? So you just open this log and you start looking at this numerical values and see, okay, so this numerical value is telling you that a tweet of an ID of, like, for example, 3 or something is basically having the most clicked or the most views of all tweets, for example. So this is the importance of data log. You can keep track of your data. You can actually process the data and know what is the mean of something, what is the most clustered or the most viewed or the most common feature in your application that people are actually targeting and viewing all the time. All right. So this is bottom line. I wanted to have this by the end of the video, but I don't know. I thought that I should speak on this area because so many students inside the lab has asked me, why do we need actually to write into files? Why don't we just print in the terminal? That's the main reason here. Okay. Or let's say in the field, that's the I swear this is the final example. All right, let's say in the field of hardware, you're working on some, for example, you're reading some temperature data, or for using some I don't know, DHT sensor or temperature sensor, and you want to save a log of these temperatures that you see when if you're working on an Arduino with Engineer Noor in Mechatronics lab, you will eventually start opening something called the serial monitor on the top right of your Arduino interface, I believe. I haven't worked on this for a long while, but I believe there's something called a serial monitor, which is basically some kind of the terminal. It's the same thing as the terminal, which you can write stuff, which you can actually print stuff into it, and you can use it for debugging purposes to know if this hardware is working, if it is reading data or not, if it's giving you all zeros or if it's giving you some incremental data or decremental data. So you should see this output as debugging thing. You want to see if this hardware is working or not. So you start opening your serial monitor and see the data that you have. Maybe you want to save this data. Maybe you are working on some servo and you want to see what exactly the angle that actually gets me to move the robot in a single direction. Maybe this angle will turn out to be something like, I don't know, maybe 35 or something. And you don't want to forget this. So in order to not forget this, the reading that you have when actually the system is working as fine as you are were anticipating, you should just write this data that you have, the data that you have been logging into the serial monitor, into a text file. So afterwards, you should only read the text file, right, and see what was the value that made me realize that the project was working well. And you will look and you'll see, yeah, it was 35. And this is it. This is the point of having something like writing into files. Okay. This is it. This is the whole idea about writing into files. And instead of manually opening the editor or manually opening the Arduino interface and looking for your script and running your script and looking and actually connecting everything, connecting your hardware, your interfacing everything with the Arduino and running your script just to see in the serial monitor the value that you have forgotten from the last run to your script. Okay, this is really more efficient. It's like by the end of the day, by the end of a hard day at work, you save the results that you have actually acquired by that day in a log, in a text file. This is the point of having a text file. Okay, this segment, I have recorded this segment when I was talking about when I was beginning to talk about the file processing, and I'm going to cut it and shift it to the end of the video just so you won't get bored. I want you to know that it is just there. If you want to listen and if you want to understand what is the reasoning behind writing into files, why is there something called file processing in programming? Why do we need file processing? This is the main objective of having some kind of log to look at after the system has been run for like 1,000 times or 100,000 times or whatever. Okay. All right. This is done. So now let's start saying how can we create a text file and hang. Okay, see what I did there when I said new and text document. This is basically me doing this manually, and we will never do it like this. Creating a text file can be done using code, can be done using Python, and this is what we are going to make. I'm really sorry, guys. And this is what we are going to make in the upcoming section or in the upcoming segment. So let's make a new script. Let's call it, for example, writing. I don't know. Let's call it write and read.py. Okay, so the field that we are talking about is basically file processing, and basically file processing means reading, writing, appending, modification on some file format. And this is actually, you can find this topic in every language. There's file processing in C, in C++, in Java, and C# and everything. The same exact concept of the functions that we will use for reading and writing can be found in other languages as well. So what we are starting now with is writing. We will see how can we first write into a script. Basically, you have 3 steps. Okay, it's just 3 main steps. The first step is basically opening a script. Let's call it a text file. A text file. Remember that the kind of files that we are working on are text files, right? So the first thing is opening a file, right? Note that we are working on my folder. You are working on your current folder that you are running your script in, which is this lab 7 script screencast. You can tell that this py file is located at lab 7 script screencast, which is the same directory here. And you can actually look at this path that you run from. This path is the same path or the same directory that the Python file is located at. It's really important. It's really important. Okay, do not, what is this? You should accept when you are writing into a file that the path that you run is basically the path that is located, that the Python file is located in. Okay, this is my directory, this is my folder, lab 7 script screencast, and this is the same directory, lab 7 script screencast, that I'm running. That's really important. These has to be matching. Okay, so the first thing is to open a text file in order to write into it, right? So how can you do this? We just use a function that's called open. This open function actually takes two arguments, right? The first argument is the file name. What do you want to write into? What file do you want to write into? Let's say that I'm going to write into a file that is called output. Let's call it output with small letters, output. Okay. Now this is not sufficient. You need to write the extension. So the extension of this file is going to be a text file. The text format is basically txt. Okay, so this part is really important. Now you would ask yourself, I have a question. Like, you want to write into this file, yeah? There's nothing called output.txt in this folder. We have nothing called output.txt in our folder, which is lab 7 screencast. The thing here, when you are opening a text file in order to write something, yeah, the file that you are opening doesn't have to be existent. It doesn't have to be there, okay? And this is not the case when you are opening a file to read from. If you are opening a file in order to read from, the file that you are reading from needs to be in the folder that they are working in this directory. So if the purpose of this opening was to read, then this output.txt should be there. If the purpose of this opening here was to write, then you don't necessarily have to have this output.txt listed in your file. Python will eventually create this if you are willing to write. Okay, so if you are willing to write in this file that you are opening and it was not listed in your directory, then Python will by default create this file for you. Okay, but this is not the case in reading. I hope you got the difference. So how can we actually specify if I'm opening this file to read or to write? Well, basically, as I told you at the beginning, that the open function takes two arguments. The first argument is the file name that you are trying to write into or read from. The next argument is basically the mode of the file. What do you want to do with this file? Okay, you opened this file. Okay, what do you want to do with this file? Do you want to read from this file, which is basically R, this is the mode of reading, or do you want to write into this file, which is basically W, this is the mode for writing, or something like this? And I know that you can guess it. W plus is basically reading and writing in the same time, okay? And it's the same thing as R plus, which is reading and writing, okay? And there's something called A as well, which is appending, but I'm not discussing this part in this section, in this file processing section in this course. So we're gonna focus on read and write. Read, come on, read and write. Okay, so we are working on writing right now, so we are going to set the mode as W for write. Now know something. This open function, when you try to open a script like this, okay, and remember, if you are opening a script that is not there, it is not listed, it is not existent yet, but with the purpose of writing, with the mode of writing, then when this line executes, Python will immediately create something like called output.txt in your directory, and then it will start like do whatever you want to do with this. If you want to write into it, if you want to do whatever you want, like that. Okay, but know something, that the open function, when you open a file like output.txt in this case, the open function returns an opened version of that file. Okay, it returns an open version of that file. So since it returns something, since it returns an opened version of the file they're trying to access, then you basically need to include a variable on the left hand side saying that maybe I will store this output.txt that I have opened. I will store the object or the returned version of it in a variable, call it file. You can call this anything. You can call this x, c, f, anything. I just want to call it file like this. So guys, this is the same thing as saying that the input function, for example, when when you are telling the user enter a number and you know for sure that the user will enter a number, what do you do before the input function? You actually always prepare something like x equal, y equal, because the input returns something from the user. That's why we are saving this in a variable. It's the same thing as the open function. The open function returns an opened version of the file that you try to access. That's why you are saving this in a variable on the left hand side. Let's call this variable xy whatever. I just want to call it as file. Okay, now you should know that file by now is the same alias for output.txt. It's the same thing essentially. They are connected. All right, so the next step is, the first step is opening a file and deciding whether you want to set the mode to writing or reading. The next step is basically bingo, writing into the file. Just as simple. Okay, so the next step is writing into the file. Now remember, what file do you write into? The file that I'm writing into is the file that I've opened, which is output.txt, which is the same thing that I've stored inside file. So file is output.txt, and I want to write inside output.txt. So we can say file, which is output.txt dot write. Okay, that's the whole thing. This is the write method, which is actually equivalent to the print function, but the print function used to print anything inside the terminal. Now write is printing anything inside that file that it will be created in our directory that is called output.txt. So let's say that we are writing a string like Ahmed, for example. Okay, now this is this next step. The third step and the final step is basically closing the file that you have opened. Okay, and you can say using file dot close. That's it. And close is a method, so it takes two parentheses. Right, now run this. Notice when I click this run button right now, just look at the left right side of my left right side of this screen right here. Look at the workspace. You will find something called output.txt created in this area. Okay, so when I run this, notice something. This is output.txt. Okay, it has been created. Now you can view output.txt using two ways. The first way is going directly to this directory of yours, going to the folder that is lab 7 and opening it by double clicking this file, and you will see Ahmed, the thing that we have written using this write method. Or since you have an editor, and an editor is basically can be used to access anything. It can be used to access PY files, and it can be used to access text files. So just open the output.txt, and you should see that this is the text file that we created, and this is the thing. This is the string that we have written. Okay, you don't have to go manually to the directory of your folder and stuff like this. You can open it from the editor. Okay, so this was writing strings. So let's say, how can we write another thing? Let's say that we are writing something like another string. Let's call it Muhammad. Okay, so if you run this, okay, and you go to the output.txt, you should see that the data have been overwritten. Ahmed was overwritten to be Ahmed Muhammad, but the problem is that Muhammad is actually, the next write statement is actually sticking to the previous one. There is no lines, not like the print function. The problem is the write function isn't that powerful as the print function. Okay, the print function used to, whenever you write something and you follow it by another print function, the print by itself, whenever it finishes printing some line, it goes a new line by default. Okay, every print, by the end of the print function, it goes a new line. That's why we don't necessarily have to go by the end of like something like this, like write an Ahmed something. We don't have to go to the end of the string and say that by the end of Ahmed we will say something like \n, because we don't need to do this because the print function makes a new line by default. So we only stick to something like write the string and let's say the print function will go a new line by itself. But the write function or the write method isn't exactly the same. The write method has to have this new line special character. So whenever you write something, just remember by the end of the data that you are writing, put a \n to make sure that the data that you are writing is basically after it's written, it's going to a new line to write a new thing. Okay, now run this. You should see that now Ahmed is in a line and Muhammad is in a line, and there is actually a new line that has been created after Muhammad. Okay, now let's try to write an integer, for example, or a float. Let's try something like 99. Okay, run this. You should see this error saying, telling you that the right function must be a string, okay, not an int. Now this is a problem with the right method. The right method basically, so what's happening here is the right method is unlike the print. The print actually accepts everything. It accepts integers, it accepts floats, it accepts like strings like this, and it's fine with it. But the right method, when we are talking about file processing, it only accepts strings. It does not accept an integer or a float. So in order to cast anything to a string, we will need to work on the str casting function. This str casting function is the same as using the int, for example. So the int actually casts anything that you write inside into an integer. The same thing goes with the str, which casts anything that you write into it into a string. So basically, the resultant or the return of this function is going to be something like this, the string of 99, which is going to be accepted and will not throw you an error. Okay, so we will wrap the 99 or any integer that we are wishing or willing to write into this file with an str function. And remember, you would want actually to go a new line. Say that you want to write another number like this. Let's call it, I don't know, 250 or 250, something like that. So you are going to wrap this in an str function, but when you run this, there's no error regarding the types anymore because the write is actually writing strings all over this 4 lines. But the problem here, you'll find that 99 and 250 is actually sticking together in one line. What we want to do is after the 99 we want to get to a new line, and after the 250 we want to get to a new line. So in order to do this, what we will be doing is after this, it's the same thing that we have done there, but remember this was a string from the start. That's why including a \n in the middle here wasn't a big deal, right? But this string is basically is separated. In order to concatenate to it a \n, we would just use the plus sign, yeah, and put a new string and put here \n, concatenate to this string as well another string that includes a \n like that, and that's it. It's done. You will see that 99 is written as a string followed by a \n, which will mean that it will go a new line to the bottom. Now run this and go to the output. Okay, let's just try this one more time. No, don't save. Now let's run this. Let's go to output.txt and you will find 99, then a new line, then 250, then a new line. All right. Okay, this is really cool, right? This is really cute, but most of the time what we will be dealing with is going to be a list, for example. Let's say that we have this list here. Yeah, this list is going to be something like these kind of numbers, and we want to write these elements into a file. Yeah, you want to write these elements into a file. So when you hear something that operates on elements, just as I told you in the previous lab, when you hear something that includes working on a collection of elements or an iterable, like the list in this case, immediately think of what? Think of a for loop. Okay, so we will need a for loop to iterate over each element. Then once you have each element in your hand, do whatever you want, write it into the file. You have this element now, write it into the file. You have this element, write it into the file. So instead of these cute writings that we have done here, let's say for x in list1 to access each element as x, let's say file.write, and we will write that x, but remember this x is an integer, right? So this is gonna throw you an error, so you need to wrap this integer by an str casting function to cast it into a string, and remember, to get a new line you will need to concatenate to it a \n. Now run this and you should see in the output.txt, which is basically the file that we are writing this into, you will see 10, 20, 30. Okay, now that was reading. I'm sorry, this was writing. Okay, just so you would know, because function is really using functions is really a big deal in your assignment, and people will be graded on how good they are organizing their code using function. Okay, so the same thing that I've done there, I can use it inside a function. So let's make a new script and call, for example, writing into our writing using functions dot y. Now let's take this cute guy to the left, to the right hand side, and the same thing that we have done, I'm going to copy it to this side. Or you know what, I'm just going to write it from scratch. Let's say that we are going to define a function and call it write into. I just want to name it like this. It's up to you. You can name it just write whatever, but I will call it write into. And let's do the same thing. Now let's say that I am going to open a script. Let's call the script something like new output.txt. Okay, and I will open it in the mode of writing. Remember that the open function returns an opened version of this script or this text file that you are trying to open. So let's save this opened version in a variable and call it, for example, file. Now this file, which is new output.txt, what we want to do is we want to have some list passed into this function. Remember that we are doing the same thing here, which was basically having a list and writing the elements of this list into this file. Okay, but where do we have a list inside a function? We actually don't have a list. What we have inside functions are generic lists. So just as we have done before, I will wait from the user to enter some real list, okay, to replace this generic list that I'm working on. Okay, so this function accept a list, whatever the list will be. Since we have a list right now, we can iterate over this list, saying for x in any list like this, for x in any list, we will say something like, okay, if you have x, which is gonna be the each element of that list, and I'm going to tell the user something like, well, we will assume that the user knows that this list is going to be an integer kind of list. Okay, we will assume that the user knows when he calls this function that he should pass an integer list, or a list of integers. Okay, so for x in any list, which is going to be every integer in that list, if you have every integer in your hand, which is x, just say file.write and write this x. But remember, the x is going to be an integer right now, so you need to cast it into a string, and after you cast it, you need to concatenate to it \n in order to guarantee that there's a new line that's going to be happening by the end of this write file. So the next write operation in the next iteration will be happening in a new separate file. All right, so this is the next step, this is the first step. The next step is writing. The third step is basically file.close. Okay, now after this operation finishes, I tend to do something like this. For example, let's tell the user that the write operation is done. It's just like a debugging message that whenever the user sees it in the terminal, he will know that the write operation is done, so he can go and check this output file or output.txt. Okay, now Let us finish the definition here. Let's go out of the function like this. Okay, now that's the definition is done. Let's call now the function and give it actually a list. Notice that this function does not return anything, and I have discussed returning versus printing in the I believe in the fifth lab, yeah. So just go check it if you want to understand what is the difference between returning and printing. A function can return, a function can print, and a function can return and print at the same time. Okay, so this is right into the function that we have already made. Now we want to call it and test it with some actual list. So I'm going to, let's create another list. Let's call it list, for example, let's call it numbers. And give it something like 100, 200, 300. And let's pass numbers to this right into. Okay, now when you run this, you will see in the terminal the print statement, the debugging statement that I have included in my function, which actually means that the write has done successfully. Like all of these write operations have been done successfully, starting from opening, writing, then closing the file. So if you now go to the your workspace, you will see something like new output.txt that we have created inside the function has been created in your directory or your tree right here. If you open this using the editor, you will see that this list that contained 100, 200, and 300, these elements are actually written into this script, into this text file. Okay? Now, there is one slight issue here. Now, if you notice something, this function, what does this function actually write into? Like, let's say that I have another list and call it, for example, nums like this, and give nums something like multiple elements like that. Okay, so let's call this function one more time and pass it nums. Run this. Write operation is done. Go to your script and open new output.txt. You will find the numbers or the elements of the second list, which is nums. Okay, the only issue here that this write into function always dump your data or dump your list that you are writing into the same exact file. Everything is happening in the same file within this function, right? But this is not the case here. What you want to do is give the user the ability of two things. The first thing is basically giving is to give the user the ability to give the desired data that he wishes to write, which is in this case we are talking about the list that we pass. Yeah. And the second thing that you should give the user the ability to do is basically give the user the ability to decide where he would want to write his data into. Okay, so the first thing that we pass is basically the data that we want to write. The next thing that we should give the user the ability to pass into the function is basically where does he want to write this data. Okay, what we have done here is only the first part, which is basically passing the data. Okay, but what's next? The problem here is that this function will always write into the same directory, which is new output.txt. So instead of this, we can tell the user to specify what is the file name that you want to be created, and hence it will be written into. Okay, so instead of having this static value right here, we will replace this with whatever file name the user will send. Okay, so the file, now the user, when he called this write into function, he will pass first the list that he wants to get the data from and get it copied into this file name, and then he will pass the file name that he wishes to write into. Okay, so we make everything as dynamic as possible. Now the write into is giving you this error now, telling you that there is a missing argument here. So now the write into should take the list itself. Let's call this let's call it list numbers. Let's call it just list for list one. Okay. So now the write into should take the list that it should work on to take the data from and dump it into the file, and it should take the file name that this writing operation will be happening into. All right. So let's say that the file name that I want to create to write list one in is basically going to be something like testing. And don't forget that you need to include the format, and the format is always in lowercase, right? So now let's run this. You will see write operation is done, okay? And you can actually do something like this. You write operation, let's say writing operation uh, into, for example, writing operation into the file name is done, okay? So we are writing into testing.txt. So we are saying that writing operation into testing.txt is now done. Now, if you go to your workspace, you will see testing.txt has been created. Now, if you see it, you will see this list that we have just created. The elements of this list are there in testing.txt. This will make it so handy when you want to use this function multiple times to write multiple different lists. If you have like multiple lists, say that you want to write now the list that is called numbers, you want to write it into a new file that is called, for example, let's call it um, new write, something like this, .txt. Now, when you run this, the first write function that you are writing into testing.txt will tell you that write operation into testing.txt is done, and you will see that just like the previous one, testing.txt has the list one, which is 90, 89, and 78, and the next write operation, or the next write into function will tell you that the write operation into new write.txt here is done. So you can see now that there's something called new write.txt, okay, which includes 100, 200, and 300, which is basically the elements in the list that is called numbers. Okay, so this is basically writing. This is writing. That's it. Okay, now let's talk about reading. Okay, so this was writing. Now let's see how reading will be done. Okay, I'm just going to start doing this without the functions, just as usual. Then, after we finish the process, the normal process without using a function, I will show you how can you make a function that reads the same thing that we have done with write into function. Okay, so consider this as writing. I'm sorry about this unplausible sound that you are hearing. I'm really sick today, so okay. So now let's talk about reading. Now, it's essentially the same steps. The first step is basically opening the file that you want to read from. Okay, so let's say that we are reading the data that we have written in this, for example, let's say testing. What we have written in testing was 90, 89, and 78. Okay, so we are trying to read this data from testing.txt. Now, what we should do is first open the file that is called testing.txt. So let's say file equal, remember that the open function has still the same thing. The open function returns an opened version of the file that you are trying to access. So now we are trying to access something called testing.txt. Remember that the how you defined this script, which is texting in uppercase, should be the same thing when you open the file, or else Python will never be able to find this certain file if it was testing in lowercase. Okay, so you want to open this file with the purpose of reading. You want to read it, so the mode is R. Okay, so an open version of text.txt will be returned from this highlighted call from the open function, and we are going to store it in file. Let's store it in file 1 since we have already file have been used in this script, so let's call it in file 1, for example. Okay, now the next step, just like the next step in the previous operation was writing, the next step should be reading the data. Okay, so I just want to show you how many read methods we have. Let's say that we will use, for example, file.c. We have multiple read functions. We have read, we have read line, we have read lines. Okay, let's try and and use read, for example, this first one, okay? And basically what is happening is, I'm sorry, we are operating on file 1. File 1 now resembles or represents text.txt. It is an alias for it. So we are reading now whatever data that is stored inside file 1. Okay? Now, remember something. When you are reading something from a file, you are reading some data from a file, you expect to have this data returned, right? You are reading something, yeah? So we are reading, for example, the things that we have here, which is 90, 89, and 78. So these data should be returned by the read method. So since this data should be returned, you will always need to store this data that is returned in a variable. Let's call this variable, for example, read data. Or let's call it data, just data like this. Okay, let's print this data and see what kind of format does this data get returned like. Okay, so let's run this. Oh, texting.txt, no such file or directory. Oh my god, I'm really sorry. It is an S. Okay, so let's run this. See, the kind of data that you have read using the .read method is basically, it's the same essentially, it's the same thing, but what has been returned is basically a string, just a full string like this. And I want you to know something. In Python, when we read some data from any file, whatever the file format is, when we read some data, what we want to guarantee is that read data is of a known structure that I can access. Okay, the data that you are reading needs to be of a known structure, and what I mean by a known structure is basically a list, a tuple, for example, a dictionary or whatever. This is what you know so far. Okay, remember in the previous lab, I told you that most of the time Python tends to return objects as tuples or lists or list of tuples. And when Python do this to you, this is something really handy. Why? Because when you have a list or you have a tuple, being able to access elements of that list or of that tuple will be so easy. Why? Because the list has an index and a tuple has an index. So we have positions, we have indices. And since we have indices, accessing an element and retrieving it will be much easier. That's why the .read method returns everything as a string, a connected string to each other. So if you have this string like this, you would want to manually separate each element on new lines. You would want to split this element when you see a new line, a \n, split the first element and split the next element when you see a new line and split the third element and it is in a new line, just in order to have a list by the end of the day. But this is really so much work. So instead of using read, there's another method that is called readline. It is not the one that we are going to use, but I just want to show you what does readline actually read. So let's use readline to read data from file 1 and store it in data, and let's print data. Okay, when you run this, you will find that readline only returns what? Only returns 90, which is basically the first line of any script. And this is kind of not really helpful to you. You want to get everything. So the last one, or the last method that you will use, and what we will be using in this video and in our assignment, is readlines. If you use readlines and you run your script, you will find the returned object, the read data that is stored inside data and that we have printed, will be looking like a very known structure to us, which is basically a list, yeah, with these square brackets here. Okay, so now if we have a list, that's actually more than we wanted. We can now access this list, we can iterate over this list, and we can cast these elements to whatever we want. We can print these numbers, we can sum these numbers, we can get the average of these numbers, right? So if you look closely, you will see that this list contains 3 elements. Each element is basically the number followed by the new line, which is the \n, the number and the \n. the number and the backslash n. And this is actually what we have signed up for. What we have done here in this for loop is basically was writing each element, okay, was writing each element and concatenating to it a backslash n. And this is what you find here. It is each element concatenated to it a backslash n. So I just want to tell you something. Let's say quickly that we have something like x 9.9. This is a float, right? If you want to cast this float into an integer, you use the int function. So you pass x to this and it gets you just 9. It truncates the fraction part. Yeah. Let's say that we have a string that represents an integer, which is x again. So if you say int x, it's going to give you the integer 9. So what will happen if we have x as 9 backslash n? If you try casting this x, which includes the backslash n, what will Python do is that it will cast the 9, the string 9, into the integer 9, and it will just overlook this backslash n. Okay? And this is the beauty of using the int function. It just it neglects this backslash n right here. So it just converts everything without the backslash n into an integer, which is in this case the string 9 is going to be the integer 9. Okay, so since we know this information, now we can work on this list that we have retrieved. Where is it? Come on, where is it? Okay, let's run this again. We can work on this list that we have retrieved. We can iterate over each element of this list of strings that represent a number and cast each element to an integer, right? So now we can make a for loop. Let's say for x on or in data. Since x is basically each element of those elements in this list, we can say that now since this element is basically a string that has a backslash into it, I just want to cast it into an integer. But what will happen here? Where are you saving this integer x? You are not saving it in anything. So we can do something like an empty list, and we can append this integer of x into it, right? So we can say something like data as int to be an empty list like this, right? So you're going to say data as int dot append and append this x but as integer now. Okay, this is going to run for each element in the read data that we have gotten from the read lines, which is basically these 3 elements. And by the end of the day, when the for loop finishes, we can print the data as int. So when you run this, this is the print for the data that we have read using the readLines method, which actually returned the elements as strings. It returns a list of these elements but as a string. Okay, we casted each element to an integer, and we appended each element that we casted into an integer into an empty list that we created, which we named data as integers. Okay, when we printed data as integers, we found that this is the same list that we have read using readLines but as integers. Okay, so let's see how can we make a function that do the same thing. Okay, there's a final step that I forgot, which is step 3, which is basically closing the file. So let's say file 1 dot close. Okay, now I just want to open the script that had the writing function, which is the write into. Okay, I had this writing function, which is write into, to the right of my screen. Now I'm going to get to make a new script. Let's call it reading using functions .py, and let's get this to be in the middle of the screen like this. Okay, now the same exact fashion that we use to make a write function, I am going to use a function to read from files. Okay, see, this is the reading operation. This is where we started doing everything. All right, So let's say that we are going to define a function, and let's call it read from. Okay, this read from, I want you to guess, does read from need a list to be passed to it? Like, what is the difference between reading from and writing into? Basically, writing into requires two things: the piece of data that you want to write and the place that you want to write into, right? But the read from, it does not require any piece of data to read into, to read from. It does not write, so you don't have to provide a list into this read from function. It doesn't have to have a list as an argument. It takes data and brings it back to you. That's the difference. So reading takes data from a file, from a certain file, and it brings it back to you. But the write, it should take the data from you and write it into some directory that you provide. So when you are reading from a file, you are not going to give this read function a list. You are not going to give it some data. It will get the data by itself from the place that you say, that you actually specify. Okay, so the only piece of info that this read from is going to need from you is basically the place or the file that you want to read from. So as we used file name here, we are going to use file name also in the reading or the read from function. Okay, so what will happen is the same steps. First, open the file name with the mode to be reading, then store this in a variable. Let's call it, for example, file. Yeah, after we open the file and had an opened version of that file that we will pass as an argument to this function, and we set it to be read access, we are now having a copy of this file name that we will pass in the variable called file. So file is the open version of the file. Okay, so once you have the file opened, let's say that we want to read from. Okay, so let's say file dot read lines. Okay, this is the function that we have settled to use. All right, now remember, as I told you, read lines here, read lines returns something. It reads the data inside this file that you have opened, so it returns something. So you need to have a variable on the left hand side to this call. Okay, so let's prepare a variable to the left hand side and call it data. And remember, whatever will be returned into data will be a list of strings. Okay, so you will need read lines return a list like this, but it's going to be a list of strings because when we wrote everything into the file system, we wrote everything as a string. Why? Because everything we wrote using the write function was casted into a string. All right, so since you have everything as a string, and this is not what I really want, maybe I would want to do something like casting these strings into integers. So I'm going to use a for loop. Since this is a list, I can iterate over it. So let's say for x in this list, which has been saved into data. So for x in data, let's say that we are casting every element in every line into an integer. But then what? Where do you want to store it? You want to store it in an empty list. Let's call it nums, for example. Okay, and create an empty list like this. So let's say that nums.append will take the casted x like that. All right, once this is done, let's just say file dot close. Okay, now that's it. We can say something like print, and let's say that read operation is done. You can actually do the same trick here, saying that write operation into this file is done. You can say read operation from the file name that we will specify is done. But this is enough for now, because if I wrote so many things, you know, the scroll bar here is going to go insane. Okay, so I just want to have this space that I'm allocated in this section of the editor. So by the end of the day, remember, the read from returns some data, right? Using the read lines, it returns some data. We had this data and we cast it into integers and we stored it into, or we appended it into nums. Since nums is the read data but in integer format, we can now return what? We can now return nums. Okay, so now we can say that this is the read from function, and we are going to use it on, let's say that we are going to read the file. Let's say that the file we are going to read from is Let's see output. Output has 10, 20, 30, right? So let's try to read from output.txt. Okay, since there is a return here, we should save this in a variable. Let's call it returned data. Return data, that's enough. I wanted to say return data from file, but whatever. Okay, so now print returned data, and let's run this. You will see that read operation is done, okay, from this print statement, from this function call, okay, and the thing returned from this function call is stored in returned data, and this is what have been printed here, which is it's the same thing in the output.txt but converted into integers using this loop right there. Okay, now how about we do something different. Now remember when I told you that returning something in a function actually allows you to use it in another function? Let's say that we will make a function and call it something like get avg or get average, and what we will give this function is basically a list. Let's call it any list. Okay, now you can figure out by now from the previous lab, which is lab 6, that there is a function called sum that we can use to get the sum of any list like this, and to get the average is basically the sum over the number of elements, which is basically the length of any list. Please refer to lab 6 if you don't remember this stuff. Okay, now let's call this in a variable and call it avg, and let's return avg. Okay, now we can use the data that we have got from this read from function that we have just created, okay, and pass it to this get average. And this is the thing that you're going to do in your assignment. Okay, that's the point of having a return, guys. That's the most important aspect of having a return in your function. The thing that you return, like imagine you have done something like this. Imagine you have done something like print nums. Okay, you have printed nums, and this happened inside the function, but you cannot actually get to work with this nums. You printed the nums inside the function, and that's it. You can't operate these nums. You can't actually interact with these nums anymore. Once the function finished calling in this part here, and it goes to another line, you have lost the nums. You cannot store it outside of the function. It is only accessible from the function itself. This is the problem with using a print instead of return. But if you have a return like this, you can make sure that whatever is calculated inside the function is returned to the user, to the outer scope outside of the function. Like what I have done here is calling the function and saving the return in a variable. Now this returned value that I have saved in return data variable is basically the nums. So I can use whatever has been returned from this read from into whatever function that I want to use afterwards. Okay, so this return data is basically nums. Now I can call get average that I've created and say something like get average and pass to it the returned data that I got from read from. Okay, but when you run this, nothing will be printed. There is no average that will be printed because get average actually returns something as well by itself. So you need to print the average return, and you can store it in a variable and print it as well. Okay, so now you're going to see the average, which is basically 60 over 3. This is going to give you 20. Okay, you can store this in a variable as well, saying that returned average, or if you want to name it result, whatever. Okay, and just print result. It's going to get you the same thing. Okay, this is the beauty of having a return in your function. You can, whatever you return from this function, you can use it afterwards in other functions, like this. Okay. I could have done something else. And instead of having two functions like this, I just wanted to make two functions to show you that you can actually do, you can actually use the returned value in another function call. That was the purpose of this function. But you can do something like this. Let's make another function and call it, let's call it, for example, we don't want to use this. We can make this function, we can define it as read, then sum. Okay, we don't want this anymore. Let's call it read then sum. So what does this function do is after it reads in read lines, and after it casts the data into integers, and after it appends the data that it casted into integers into nums, I just don't want to return the list as it is like this, but what I want to do is returning the summation of this list. Okay, so now we have changed the name of the function to read then sum. So what will be returned here is basically the summation of these elements, which is basically going to be 60. So let's print returned our read then sum. I'm sorry, the variable is called returned data, this variable. Okay, so let's run this. You should have 60. Okay, so let's see the exercises. I think there are 3 or 4 of them. Okay, so the first program is telling you that you should make a function that write into. Okay, this write into function takes 2 arguments, which is the list that you want to write and the place that you want to write into. Okay, so the function call should be something like this, giving the list and giving the name of the file that you want to write into. And when you run this, you should see a new file .txt has been created and added to your directory or your workspace. When you open this new file, you should see the numbers in this list in this vertical alignment like this. Okay, and we have done already that. Okay, but let's just do it one more time since we want to use this data in our script. Okay, so this is the function, and the write into was basically this function right here, so I'm just going to copy it. Okay, so this is the write into function. Now let's call the function let's call the function write into. All right, and give it list 1 like that. We should run this. Oh, sorry, write into takes 2 arguments, which is the list and the place. Let's call this just as the example, new file.txt. Now let's run this. The write operation to new file.txt is done. Now go to your workspace and you should see new file.txt having this elements of the list. Okay, now let's see the other one. The next one is telling you write the evens. It takes a list. It's a write function that takes any list and it takes the same thing. It takes a file name just like the previous example, but now it doesn't write every element. It works on this list. Okay, it doesn't write every element. It only picks the even elements and it writes them. So for example, this function call is looking like this. It takes list2 and it creates or it writes this list2 in a file that you will create. For example, you might call it evens.txt. Evens.txt will be created and we'll be having the evens from this list, which is in this case 10, 40, and 50. Okay, and remember, if you look closely in this evens.txt, you have something like a header here. So do not forget to include it. So let's see how to make program 5. Let's call the function. Let's call it define and let's call it write evens. Okay, now write evens takes any list like that, and write evens also takes the file name that you want to write into. Okay, so let's say that first we will open the file, and what file we are opening is file name with the purpose of writing. Now we want to write this header first, which is evens. So what we are going to do is basically file.write and write this string, which is evens, and do not forget to go to a new line. Then you will start this loop of yours to write the evens elements of this list, which is in my function here is called a generic list, is called any list. So we will say that for x in any list, let's if you did something like this for or file.write and you picked this x, which is an integer, and you cast it to a string and you said something like string x plus backslash, and this will actually write every element. But this is not the case. You are picking only, you are checking only if the element is even or not. If it's even, then you should write it. So instead of writing every element, we will include an if statement saying if x was divisible, if you divided x by 2 and it gave you something like 0, which means that x is even number, then just indent this inside the if, saying that this will only happen if the x was an even number. Okay, so that's your code here, and we can actually by the end of the function say that file.close, and then we will have a print statement saying that write is done. Okay, let me remove just the white spaces here. Okay, so this is your function. Now let's call the function, which is called write evens, and give to it list 2, which was in this example. Let's copy this. Okay, and give it write evens list 2. All right, and then let's specify the name of the file that you are writing into, which is evens in this case. So let's name this as evens.txt, and let's run this. You should see write is done, and this is regarding the write evens. If you go to this workspace of yours, you're gonna see evens.txt, which has the header, and then it has the evens from list 2, which is basically 10, 40, and 50. Okay, so this is write evens. Let's check the other one. Now the third program, or the third write program, is telling you that you should now make a function that is called write even indexed. Right, not the even elements, but the even indexed elements, meaning that the elements that lie in the even positions or the even indices. Like for example, this element here, which is at index 0, which is even, then the index or the element at the index of 2, then the element at the index of 4, 0, 2, 4, like this. Okay, we are not picking the even elements themselves. No, we are picking the even indexed elements. There are multiple ways to do it. Maybe I will do it in 2 different ways and pick whatever suits you. Okay, so let's make a function and call it define write even indexed, and this takes any list like this, and it takes a file name. Now open the file first with the purpose of writing. Now let's say that there a header somewhere. Yeah, there is a header, but let's name the header even indexed. So let's say file dot write even indexed elements, and let's say \n. Now our for loop is actually the tricky part. Now if you said something like for x in any list, you can do this, but the thing that I'm doing right now is something like that. Let's say for x in range. Why did I use range? Well, the first method that we can solve this problem with is basically having the for loop variable, which is x, or for loop iterator, to be as the index itself. So to make the x as the index, we need actually to iterate over the indices. If I did something like this for x in any list, now I'm iterating over the elements. Now I have the elements themselves, and this is not what I want. But if I said something like for x in range, and I started the range from the first index of any iterable, which is any index starts at 0, till the last index of this given list, which is basically is going to be len of that any list. Remember that the range function, by default, the end is not included, and by default the length of the function is not included with me. What I mean by this is if I said something like x 2, for example, and 3, this list has indices of 0, 1, and 2, but the length is 3, so length of x is 3, which is basically out of bound. I don't have an index at 3. I have 0, 1, 2. So don't worry about having length of any list as your end, because in every case scenario, len of any list is basically an index that is not included. Like look at this example, 0, 1, 2, len of x is going to be 3, and the range function does not take the last one, which is 3, and this is fine. It stops before 3, which is going to stop before at the last index, which is 0, 1, 2. Okay, so now I am picking the indices, saying that x is going to be the index from the starting index of this list till the last index of this list, which is going to be before the length of any list. Okay, now since x is the index, I can say something like, I can do whatever. If we want to get the evens, if x is the actual uh, if x is the actual index, like in this case, you can do something like this. You can say that the step is 2. Since the step is 2, this means that every x that you get is basically an even index. A step of 2 means that you're going to get 0, 2, 4, etc. Right? So if this is the case, you can do immediately, you can say file.write this x, but after you cast it into an integer, and just add e\n. Okay? This would work. All right, I think Yusuf Atallah did this in the lab, I believe. Okay, if you don't want to do this, if you don't want to have a step of 2, you can check every index. Now we have all indices from 0, 1, 2, 3 to whatever the list length will be. You can see if the index itself, when you divide it by 2, if it gets you a remainder of 0, then this means that the index is even. So in this case, you can actually write that element because the index is even. Okay, so now we will close like this, and we can say print, or let's say write operation is done. Okay, now let's call this, and we are working on this list. I think it's the same list as before. It is list 2. Yeah, it's the same list. So let's say write even indexed and give list 2 as argument, and let's say that we are creating a file that is called even indexed.txt. Okay, now let's run this. Write operation is done. Let's see even indexed. Oops, I did a very naive mistake. What I have been writing here, guys, was the index, and this is not what you want. You don't want to write the index. What I have written is the index of 0, 2, and 4. Okay, but this is not what you're looking for. You are looking for the element under each index of these elements, the element under 0 and the element under 2 and the element of 4. It's a good thing actually that I made this mistake. Okay, so instead of writing the index itself, let's say that we want to get the element that is under that index from any list. Okay, so this gets you the index from that list. So if you run this, you should see now the elements themselves, which is 10, 23, and 41. Alright, so this is the first way, and if you would like to have step of 2, it's going to give you the same thing. If you are stepping by 2, you don't need the if statement anymore, and you would remove one level of indentation here. When you run this, you should see the same output. Alright, so this is the first method. You can write this with a different technique, making something like, I'm going to comment this out. Okay, you can use the for loop as the element, just as we were using before, as the element itself. But instead, we are going to use a new method. This is why I didn't want to introduce you this other technique, because I haven't talked about a method called index. Some of you have searched for it and they know it, but not all of you. Okay, so if you did something like, if you did something like for x in the list name directly, for x in any list, which in this case x is going to be the element itself from the past list, all right, we can say something like this. If the index returned from that element, what does index method do? I'm going to illustrate this really fast. Let's say that we have a list that is called, okay, x, and x has indices 0, 1, 2, 3. Notice that 10 is at the even index, and 30 or 0 is at the even index, and 30 is at an even index, 0 and 2. Okay, okay, so if you did something like x dot index, oh my goodness, okay, let's name the list something more meaningful so you just don't get confused with this. Let's call it list. All right, so if we said list dot index, index is a method just like append and just like sort and just like count. So index, what does index do is that it takes an element, let's give it something like 30. Okay, you give it an element and it returns where is that element located in this list. It returns the position, or it returns the index of that given element from that list. Okay, so 30 is at 0, 1, 2, it's at the index of 2, so it should return index of 2. This is what index do. Okay, maybe this is the first time for you seeing index, but if you understand the first method, which is basically iterating over the indices using the range function, then this is fine. You don't have to go through this one. Okay, but if you want to understand both methods, then this is the next or the other method that you can work around. So you say for x in any list, in this case, the iterator, which is x, is going to be the element itself. Since you have the element itself as x, you can say, or you can check, or you can get the index of that element. You can say, if you have the element which is x, please get me the index of that element from its position in that list. If the index of that element, which is x, if the index was divisible by 2, and it gets you a remainder of 0, this means that the index returned here is an even index. If this is the case, then please write, in this case, what you will write here is basically x, since x is the element that you are checking. Okay, what we used here is to check the index of the x. If the index of the x was, if you divided it by 2 and it gets you a 0, which means that it's an even number, or the index is an even number, then this means that now I can write this element, okay, which is x in this case. So we can write x now, which is the element, plus backslash n. All right, if you run this and look at even index, it's going to give you the same exact result. So you have this method and you also have this method. Okay, whatever suits you, just work with it. All right, maybe this is the hardest question out of them all. Okay, so I'll just need to comment one of them, because one of them should only work. Now let's see the next program. Okay, now we are talking about reading. We have illustrated reading, and we know that we open a file in a mode of R, or read, then we read the lines and store whatever we read from this file in data, and then we close the file, right? So now the data that we have written inside the even.txt, which was the even elements from this list, which was 10, 40, and 50, which was program 5, we should now be able to read it. So the program is telling you read then average, okay, or read an average, and it takes only a file name to read from. So it's gonna read from evens, and the average of these elements is going to be 333, whatever. Okay, so let's create a function and call it define read an average, and it should take only a file name. Then we're going to open that file name with the mode R, store it in file. Now it should only read, so we're going to say read lines, and read lines will return your data. So let's store this in data. Okay, if we have the data, remember that the data returned is a list of strings, right? So we need to cast it into for x in data and say integer of x, and this needs to be appended into another empty list as the integers or a list of integers. So say nums append like that. Then by the end of the day, just say file dot close, and let's say print, and let's say read operation is done. Operation, come on, come on. Okay, so this is the function. Now, by the end of the day, what you have done here is that you have read and appended the elements after casting them to integers, but you need also to get the average, right? So let's say that the average is going to be the sum of the nums that we have appended over the length of that same list, which is nums. Now return avg. This is the function. Now let's say that we are going to work on the evens file, which had 10, 40, and 50. Okay, so now let's call the function. Let's say read an average and give it evens.txt. Okay, remember it returns something, so let's save this as returned avg and just print return avg. Okay, if you run this, there is an error. Yeah, the problem here, and I intended to do this in front of you, was that evens.txt, the first line isn't really an integer. It's not even a string that represents an integer. Okay. Okay, so the problem here is that evens.txt, the first line isn't a string that represents an integer. So whenever Python tries to read the first line, which is the first element in this data that we have read from this file, basically it will give you an error when it tries to cast this evens.txt, or if this it's gonna try to cast this evens colon, this first line, into an integer, and it's gonna fail, telling you that int work with any number with the base of 10, meaning that the string should represent a number in order for me to cast it into an integer. But what you have here is a string that does not represent a number. This evens, then the colon here, this is string. These are English letters. Okay, so you cannot actually cast this to an integer because this does not actually represent an integer in the first place. So in most cases like this, in natural language processing or in text processing in general, you are going to work all the time with tables and Excel sheets and text files, and most of the time you're gonna have this table or Excel sheet starting with a header telling you that this table that you are looking at is basically a column of even numbers. So in most case scenarios, you would want to know a way on how can you skip the first line, which is most probably is going to be a header. Okay, so how to skip the first line in any script is just by doing something like this. Use a function called next before you read, okay, before reading. All right, next, and then give to this next function the file that you are reading, which is in this case file that we have opened and stored in file. Okay, so when you say next file, what does next do is that it takes the cursor from its initial position, which is at index 0 here, and it moves it to the after the first line finishes to the next line. So the reading starts from this cursor. The cursor is now at the first index at the second line, so it can read lines starting this position till the end. This is what next do. So basically, what does next function do is that it skips the first line. It is not necessarily the first line, meaning if you did something like if you said next one more time, next file for example, so it's gonna skip the first line, then it's gonna skip the next line, then the reading is going to start from the third line, like here. Okay, so it skips a line. All right, so if you used one next function, it's gonna skip the first line, and you give this next function the file that you wanna skip the line from. All right, so if you read this right now, if you run this, everything will be fine, and the first header line will be skipped, and the reading process will start from the next line, which starts at 10. Is gonna sum everything and divide them by 3. Then it's gonna give you this summation of, or average of, 53.3333. Okay, so this is read and average. Now let's see the final program that we have. Well, this is basically the most this is basically the question that is really similar to what you will see in your assignment, which is basically after you write the events, see what we have written in the events.txt in the program, I believe in program 5. Yeah, in program 5, we have written the event elements inside the script, called it event.txt, right? But what we are doing now in program 8 is that what you have written inside even, you're not going to only read it and get the average like the program 7 that you have just created. No, you are going to read it, and you are going to check these elements if they have a frequency or not. You're gonna check how many times does each element appear in this list. You're gonna get the frequency of each element in this events.txt. Okay, and when you hear the frequency table name or the mode, you should always remember that you're going to use the counter function. Okay, so we are going to use all of this inside the function. All right, so let's get the final function done. It's frequency table in a file. We should have this frequency table printed or written in a file. Remember, this is a write function. You should write this frequency table in a file instead of having it in the terminal. So okay, so now let's create a function and call it frequency table in a file. All right, this function takes any list, and remember that this list that we are reading, or this list that we will give this function, is basically the list that was in the events, which is basically 10, 40, and 50. Okay, and it takes a file name in order to write this frequency table into, which is in this case we're gonna create something like frequency table.txt, or name it whatever you want to name it. Okay, so I just want to take this function header. Now let's go to VS Code, and let's say there's a definition here. I'm sorry, define. Okay, it takes a list, it takes a file name, right? So how do we usually create a frequency table? Yes, we need the counter function. So I'm going to go, well, I should do it like this. I should go, you know what? I'm going to do this in a separate file because this is really cramped. So let's say frequency table in file.by, and let's say that this function needs, from the collections module, it needs to import the counter function. Okay, and notice that I've done this outside of the function. Now let's say that this function is going to take any list that we are working inside the function locally, and it's going to count its elements. So it's gonna count the elements of any list. Now let's save this in a variable, just as we used to do in a variable called c. Let's say c.mostCommon, and most common, what it does is that it takes whatever returned by the counter and put them in a list that is ordered and sorted from the highest frequency to the lowest frequency. So we save this in a variable called all frequencies. All right, so this is the part where we have actually, now you can say that all frequencies has a list of doubles. All right, since we have a list of doubles, what we can do is actually create the frequency table. Notice that the frequency table here has a header, which is number and frequency, but not like your usual frequency table that we have done in lab 6, I believe. You wouldn't do a print because now we are working on files. So basically, you're gonna need to open your file first that we are working on, which is the user going to provide in the file name argument, and say that you are using this file to write. So set the mode as W. Okay. Okay. Now you open the file. Now let's say that inside the file we are going to write first the header, which is number, okay, then backslash t. Yes, backslash t can be written inside the right method, just like a print. And we have the frequency, all right? And do not forget the backslash n to get it to a new line. All right, now let's make a for loop. Let's say for x in all frequencies. Remember that all frequencies has a list of tuples, and this list of tuples contains, each pair contains the number, which is the element, and its frequency, right? And both of them are integers, right? So we would want to convert every one of these, the element of the tuple which is at x of 0 and the frequency of the tuple which is x of 1 to an integer before we can write it. Yeah, so let's say for x of all frequencies, it's going to be, x is going to be the tuple itself from all frequencies. Please, if you don't remember this, get to the 6th lab video or screencast in order to revise how did we make the frequency table. The only changes that we are making right now is that with instead of writing or printing into the terminal, we are writing into a file. Okay, so now x is the tuple. What you want from this tuple is basically writing the first element, which is basically the number or the element itself, saying x of 0, but basically you cannot write x of 0 because it's an integer, so you're gonna cast this to a string. All right, and we will put an if string on all of this, and inside the curly braces this guy go here. Okay, then we'll have a backslash t, right? Then another curly brace, and we will put x of 1, which is basically the frequency, but you cannot put x of 1 as it is. You know, you need to cast it into a string. All right, and there is a quotation by the end. Okay, so I think this does the trick. Now let's end the for loop and say file dot close like that. Right, and let's by the end of the day say print and tell the user that the write operation is done. Now let's call the function and let's try. I know that we need to work on the list that is saved inside the events. You see, you need to work on this list. Okay, you need to read this list and work on it. All right, so we didn't make a function that read from a file, that only reads. What we have done so far regarding reading is that we have made a function that read an average, but we have not made a function that read only. But before doing that function, let's test this on any list, any normal list like that. Let's say, for example, 10, 10, 10. So this is my mode, 3, 3. That's going to be have a frequency of 2, and 4 is going to have a frequency of 1. Okay, so let's call frequency table and give it list 1, and let's say that's going to be created, or the frequency table that this loop is generating is going to be created in a file called frequency table version 1, for example, .txt. Now run this and the write operation is done. Now look at your workspace. You should have frequency table version 1, but there's a problem. Yes, I know. You can tell from this that I forgot to make a new line or create a new line after each write method. Okay, so there's a backslash n here. Okay, so run this and you're gonna see that this is almost what you want, but there is some kind of a narrow space, so you can actually shift this with another backslash t in the middle. Okay, so run this and this is your frequency table. This is exactly what the output is asking, just the list is different. It's working here on 10, 40, and 50, which is actually was inside the events.txt, but now we are working on another different external list. Okay, now this is exactly what the frequency table function should do. The only thing that is different is that we are not actually abiding by the rules, meaning that this function or this question is asking you to create a frequency table that reads from the events, and the list that you have read from the events, which is basically this 10, 40, and 50, should be the one that you pass, should be the returned even list that you pass into this frequency table function. Okay, so instead of having a frequency or an external list that like the one that I did, I need to make a function that only read and return the read data. And actually we have done this, but yeah, we have done this, so there's no need to do it again. We have done something called reading using function, and we have done read then sum. I'm just going to edit this slightly. So read then sum, it opens a file in the read mode. It reads the lines in that file that you have opened and stored in file, and it saved the read lines into data. Then it loops through the list of strings returned by read lines, and it takes each element of that list of strings and it casts it to an integer, then appends it to an empty list that we created before the for loop, call it nums. Nums is basically the mirror of data. It's the same thing as data, but as integers. Data is the same thing as nums, but as strings. Okay, so instead of returning the summation of these numbers, we are going to return the numbers list as it is. Okay, so this is read. Let's call it just read from. Okay, and let's test it before we do anything. Let's do read from and give it the file name evens.txt and save this in a variable, call it returned evens list. Let's print returned evens list and run this. Yes, there's a problem here. I really forgot this again. See, this evens.txt that you are reading from, if you remember this skipping line that I've talked to you about, where is it? Where is it? This is evens.txt. It has a header and it cannot, there's an error that will occur when you try to cast this x, which is the first element of that list, which is basically the header, is there's an error that will occur if you try to cast evens into an integer, because evens is a string that does not represent any integer. So like we have done in this program, where was it, in progs here, we use something called next file to skip a line. So basically we want to skip only the first line, so we're going to use the next function only one time. Alright, so let's go here and say, before the reading operation line, we are just going to say, please just skip the first line in this file and start reading from the next line, which is from the 10 here. Put the cursor here. Okay, so if you run this, the returned list is going to be something like this. And this is the list that we want to pass to frequency table, not list 1. Okay, so let's cut this call here and let's say that what we will be passing to frequency table in file is basically going to be the returned even list that we got from the read from function call that we have used even.txt with. Okay, now run this and look at your frequency table. Okay, you should see, where is it? You should see, since you have the evens as 10, 40, and 50, your list is basically like this. You don't have any repeated elements. So the count or frequency of each element is 1. That's why when you open frequency table version 1, you're gonna see 10 appeared one time, and 40 appeared one time, and 50 appeared one time. This is the hardest, I believe, the hardest question. Okay, because this is an integration of two functions together. You use the function, you get the return from that function, and then you pass that returned list into another function call. Okay, I know that this might sound a little bit too much, but just repeat this last half hour of this video, and I believe you're gonna get it good, inshallah. And if there is any problem, just message me or mail me. Okay.